Okay, so we're going to do Unit 2, Day 1, absolute value functions and their graphs. So this unit is all about absolute value. So we're going to look at the graphs today in more detail. So things are going to change from Unit 1 primarily because we have this guy here. So the f of x, that really means y equals, remember. The inside, all of this is still your horizontal shift. Okay, it's going to go left, it's going to go right. So what you would want to do with your horizontal shift is set it equal to 0. So set the inside equal to 0. So that mx plus b, we're going to set that equal to 0. And then solve for x. So subtract the b from both sides. And then divide by m. So that will be your right or left movement. Now, as you can see, that's what we get. So that is referred to as the axis of symmetry. That's kind of the imaginary line that goes right down the middle of your V. Remember, these are V-shaped graphs, okay? Which also in turn becomes your x-coordinate of your vertex, your key point. Now this plus C, that is still your vertical shift. So that's your up or down, okay? So notice how that goes right here for your y-coordinate of your vertex, your key point. Now the other thing we want to talk about is what's out front. So if it's positive, it opens up. If it's negative, it opens down. So we're going to kind of refer to that as the D of O, the direction of opening. Does it open up? Does it open down? Okay? Now, these graphs are going to get a little wider, a little skinnier, and you can kind of tell that from the M, okay? The M, think of that as your slope, okay? Remember that in Algebra 1, your slope? Now, if that absolute value of M, if that is greater than 1, okay, so whatever your M is, take the absolute value. If that's greater than 1, we're going to have what's called a horizontal shrink. Okay? So in a sense, your graph is going to get skinny. Okay? Now, if the absolute value of M is less than 1, we're going to have a horizontal stretch. So your graph is going to look like it's going to get a little more fat. Okay? So we're going to look at, a couple of each type or one of each type at least. Now, if that absolute value of M is equal to 1, that stays the same. So that's kind of like what we did in Unit 1, all the basic graphs, all the basic V's. Okay? All right, so kind of a preliminary example here. We're going to find the vertex, the axis, symmetry, direction of opening. So the first thing you always want to do is kind of set that inside equal to 0. So set that inside equal to 0, solve for x. So that means our graph is going to go to the right one. So your vertex is going to be 1 something. Well, that something is the 5 in this case. Okay? The axis of symmetry, the A of S, is that x equals 1. And then the D of O, direction of opening, look out front, see how it's positive? It opens up. Okay? So this was kind of an old school one we did in Unit 1. You should have been able to say that this goes right 1, up 5. So there's your key point. But again, kind of get used to setting that inside equals 0 because it's not going to be as easy in this unit. All right, letter B. So again, set that inside equals 0. This will get your right-left movement. So you guys should figure this out, that it goes left 3. So your vertex is going to be -3, -2. okay? Your axis of symmetry is what we just found out there, that x equals -3. Again, that's that line that goes right down the middle of your graph. And then the D of O here, direction of opening, see how we have the minus out front, so that's gonna flip or reflect that x-axis, so this opens down. Okay? So, that was a basic one we did in Unit 1 as well. Now it's getting a little more challenging because we got that 2 in front. So that's kind of like your slope, your M. So again, set that inside equal to 0. Solve for x. And this time we get x equals -1/2. So that means your vertex here is going to be -1/2, comma, -4. So this graph would actually go to the left 1/2 and then down 4. Okay? So that's why it's important to get in the habit of setting that inside equal to 0. The axis of symmetry is that x equals -1/2, and the direction of opening here is up. It's positive out front. Okay? Last one on this slide. Again, start with setting that inside equal to 0. This will get your horizontal shift. So this would actually go to the right 2/5. So that's why it's getting a little more challenging in this unit. So we go to the right 2/5 and then up 3. So that's your key point, that's your vertex. The axis of symmetry, that's what goes right down the middle of your graph again. X equals 2/5. And your direction of opening, this time it opens down because it would flip the x-axis or reflect the x-axis because of that minus sign in front. Okay? All right, so let's look at some graphs now. So we're going to start with a basic graph. We did this in Unit 1. So this one hopefully is not that big of a deal. So you should be able to see that this flips the x-axis. It goes right 1 and then down 1. Okay, so we did, this is a basic one, and we know it's a basic one because of the number in front of that x. Since nothing's there, there's really a 1. Now we don't need that, but that's what we're kind of looking for in this unit. So that right 1 down 1, and then it flips. So this V forms like such. Okay, so your domain x such that x is an element of all reals. The range y such that y is less than or equal to -1. So remember the other ways to represent that. Kind of a start and stop. So domain goes left and right, range goes from bottom to top. So be careful we get that closed bracket with that range. So if we take a walk on this graph from left to right, we're going uphill. We hit that turning point, then we're going downhill. So we're increasing from -infinity to 1. Okay, we hit that turning point, then we're going downhill. So we're decreasing from 1 to positive infinity. So the other way to represent that would be like such. Again, these are roundish brackets always. The domain is when you have that square bracket you have to be worried about. Okay? So the turning point was at 1, -1, and that is a max in this case. Remember, that's referred to as your extrema. So the x-intercepts, we actually don't have any on this particular graph. Our graph does not touch that x-axis. The y-intercept is 0, -2. Okay, and then end behavior, as we go to the left, what's happening? X is approaching negative infinity. Y is approaching negative. I don't know why this is not right. Come on. All right, so I'm not sure why that's not coming up. So X approaches negative infinity, Y approaches negative infinity. That's your left-hand end behavior. The right-hand end behavior, X approaches positive infinity. Maybe I need to bring this up here. And Y approaches negative infinity. Okay? Now, just one other thing before we move on this one. That axis of symmetry, that's what goes right down the middle. So that's X equals 1 in this case. Okay? That kind of comes from your right 1 movement. That's why you set that inside equals 0. Direction of opening would be down in this case. Okay? All right, so this is a new one because of this 2. So this is kind of brand new for us. So let's see what happens. So again, set that inside equals 0. So if we set 2x minus 5 equals 0, now I'm going to kind of cut to the chase here because I don't have much room. But you would add the 5 to both sides and divide by 2. So x equals 5 halves, okay, which is 2.5. That is your axis of symmetry. Okay, that's your axis of symmetry. That means this graph goes to the right 5 halves, or 2.5. Okay, now we did not move this up or down, we didn't flip it, so my key point is right there. Okay, that happens to be the turning point. All right, so we go right 5 halves, and this is kind of where, you know, an XY chart would help us out. That 2 is your slope. So if we kind of go up to right 1, we're going to get to this guy here. That's a nice point. Now you can see we go up to right 1, and then we have the reflection on the other side. But that's how we graph this. Now, can you see how that graph is getting a little more narrow? It's getting a little skinny compared to the normal. Okay? So we do need to kind of refer to that in the transformation. So this, you know, that's a horizontal shrink from left to right. So for our purposes, we're just going to put skinny to help us out. But that is a transformation. You kind of need that in there. All right, your domain. X such that X is an element of all reals. The range, Y such that Y is greater than or equal to 0. Okay? Now the other way to represent that again is negative infinity to infinity. And from bottom to top, it'll be from 0 to positive infinity for the range. All right, if we take a walk on our graph from left to right, see how we're going downhill? So we're decreasing, we hit that turning point, then we're increasing. So from left to right, we're decreasing from negative infinity to 5 halves, okay? So that's why going back, that really helps us out. That's your axis of symmetry, X equals 5 halves. So that helps us with our intervals. Then we're increasing, sorry, let's erase that. Then we're increasing from 5 halves to positive infinity. All right, so again, the other way to represent that, negative infinity to 5 halves, right there, and then increasing from 5 halves to positive infinity. All right, so the x-intercept, it touches at 5 halves comma 0. Remember, that's your 0 of the function. The y-intercept is 0, 5. That's where it touches the y-axis. Your end behavior, So as we go to the left, x is getting smaller, y is getting bigger. So x approaches negative infinity, y approaches positive infinity. That's your left-hand end behavior. Right-hand end behavior, as you go to the right, x is getting bigger, x approaches positive infinity, y is getting bigger, it's going up. And there you have it. So that would be, because of that 2, that's your slope. Things are changing now. So the V's are going to get smaller or skinnier from left to right, or wider from left to right. So this skinny is really a horizontal shrink from left to right, if you think of it like that. It's like you're squeezing it from left to right. All right, one more example. All right, so let's see what happens here. So again, set that inside equals 0. It's kind of where you want to start. So that 1/2 x minus 1 equals 0. So you would add the 1 to both sides, and then multiply by 2 both sides, and you get x equals 2. That's your axis of symmetry. That kind of divides the V into 2 parts. So that means we go to the right 2. Now some of you would look at that and say right 1. But again, because of this guy here, that changes. So you gotta be careful. All right, we also go down 4. Okay, and there's going to be one more transformation. We'll talk about that once we look at the graph. So if we go right 2 down 4, that puts us right there. That's your key point. That's actually your turning point. 2, -4. And I need to go back real quick, because I forgot to mention that the fact that this is a min value. So I should have said that as we were doing that. So there you have it. Okay, so we don't know if this is a max or min just yet, or do we? This graph opens up, so this actually is a min value. Okay, now to graph this, this is kind of where you use your slope. See how that m is 1/2? So if I go up 1 right 2, that puts us right there, up 1 right 2. Now we have the reflection over here, so we're using kind of reverse slope. So that's how you're graphing it. Okay, so your domain, well, first of all, transformation, see how this got a little wider? So it's a horizontal stretch, so it gets a little fat, if you will. So there's your transformations. Now, your domain, x such that x is an element of all reals. The range, y such that y is greater than or equal to -4. Okay, so the other way to write that, -infinity to infinity. And then remember, the range is bottom to top, so -4 to infinity. Okay, let's take a walk on the graph. We're going downhill from left to right. We hit that turning point, then we're going uphill. So we're decreasing from -infinity to 2. We hit that turning point, now we're going uphill, we're increasing from 2 to positive infinity. So the other way to write that, -infinity to 2, and 2 to infinity. Kind of a start and stop. Now, the x-intercepts, we actually have 2. Okay, we have this guy here, and then if this graph continues to the right, it's kind of off the screen. Where's it going to hit? Well, on the left side, it's at -6, 0. On the right side, can you kind of picture where it's going to hit? It's going to hit at 10, 0. So there's your x-intercepts. We actually have 2 on this case. The y-intercept's a little easier to see, 0, -3. All right, and then end behavior. So as we go to the left, what's happening? X is getting smaller, so it approaches -infinity. Y is getting bigger, so it approaches positive infinity. That's your left-hand end behavior. Right-hand end behavior. X is getting bigger, it approaches positive infinity. Y is getting bigger, Y approaches positive infinity. Okay? Now remember with these guys, to graph it, you could always use your XY chart to help you out. But as you can see with this unit, the graphs, the V's, the absolute value graphs are getting skinnier and a little more wider. Okay, so that's the big effect in this unit. So that concludes Unit 2, Day 1.